If you have ever watched an AI forget something you told it 10 minutes ago, or seen it cut off a long answer without finishing, you have already run into the two most important limits in all of AI, tokens and context windows. By the end of this video you will know exactly what those terms mean, why every AI product on the market is racing to improve them, and what you can do right now to work smarter with any AI tool you use. So let us start with the simplest possible definition of a token. A token is a small chunk of text. Not a word, not a letter, but something in between. The word running might be one token. The word unbelievable might be split into 3 tokens. A single punctuation mark is often its own token. Before a language model reads a single word of your message, it converts everything you typed into a sequence of these tokens. The reason AI models work with tokens instead of raw words or raw letters comes down to math and efficiency. Language models are trained on enormous amounts of text, and using tokens lets them represent rare words, names, and technical terms without needing a separate entry for every possible word in every language. A vocabulary of around 100,000 tokens can cover virtually any text you throw at it. To make this concrete, here is how tokenization works on real text. Take the sentence, "The quick brown fox." That is roughly 5 tokens. Now take a technical sentence full of uncommon words, and the token count can double even though the sentence is the same length in characters. This is important because AI providers charge you by the token, and models think in tokens, so your costs and your results both depend on token count. Now that you understand tokens, the context window is easy to explain. The context window is the maximum number of tokens a model can see at one time. Think of it as the model's working memory. Everything inside that window, your instructions, the conversation history, any documents you pasted in, and the model's own responses, all of it has to fit inside that limit. Anything outside the window simply does not exist to the model. Here is a useful mental image. Imagine the context window as a physical desk. You can only spread out as many papers as the desk has room for. If you add a new paper and the desk is full, something else falls off the edge. The model does not decide what falls off in a smart way. It just loses whatever is oldest. That is why an AI seems to forget earlier parts of a long conversation. Here is what actually happens when you hit the context window limit. The model starts losing the beginning of the conversation. Your original instructions, the context you carefully set up at the start, gone. The model keeps generating responses, but it is now working without some of the information it needs. The quality drops, the answers become more generic, and sometimes the model contradicts something it said earlier because it can no longer see it. Different models have very different context window sizes, and those sizes have been growing fast. Early versions of popular language models had context windows of around 4,000 tokens. That is roughly 3,000 words, or about a 12-page document. More recent models offer 128,000 tokens or more. Some research models are pushing past 1 million tokens. That shift is not just a technical footnote. It changes what you can actually do with these tools. The race to build bigger context windows is one of the biggest stories in AI right now. A larger context window means you can feed an entire codebase into a model and ask it to find a bug. You can paste a 200-page research report and ask for a summary. You can run a customer service session that remembers everything from the first message to the last. These things were impossible or very difficult with smaller windows. But bigger is not always better without trade-offs. When context windows get very large, models sometimes struggle with what researchers call the lost-in-the-middle problem. Information at the beginning and end of the window tends to get more attention than information in the middle. So you can have a 128,000 token window and still have a model miss a key detail that was buried in the center of a long document. There is also the question of cost and speed. Processing more tokens takes more compute. If you are calling an AI through an API and you send a 50,000 token prompt every time, your bill adds up fast. And the response takes longer to generate. Bigger context windows are powerful, but using them carelessly is expensive. Knowing all this, here are 3 practical things you can do right now to get more out of whatever context window you are working with. The first one is to put your most important instructions at the very beginning and repeat them briefly at the end. Because of how models weight attention, the edges of the context window get the most focus. Do not bury critical instructions in the middle of a long prompt. The second strategy is to chunk long documents rather than pasting everything at once. If you need to analyze a 50-page report, break it into sections and process each section in a focused conversation. Then combine the outputs. This keeps you inside a manageable token range and often produces more accurate results than throwing the whole document in at once. The third strategy is to know when to start fresh. A long conversation that has been running for an hour is a context window problem waiting to happen. If you notice the AI losing track of early instructions or starting to give inconsistent answers, do not keep patching the same conversation. Start a new one, paste in only the most relevant context, and continue from there. A shorter focused context often outperforms a bloated one. There is one more concept worth knowing here, and that is retrieval augmented generation, or RAG. RAG is a technique that gets around context window limits by storing information in an external database and only pulling in the relevant pieces when needed. Instead of pasting an entire knowledge base into the context window, the model retrieves the 3 or 4 most relevant chunks and uses those. It is one of the most important architectural patterns in production AI systems today. RAG matters because it shows that the solution to context window limits is not always a bigger window. Sometimes the smarter move is to be selective about what you put in the window in the first place. Engineers building AI applications think about this constantly, and as a user you can apply the same logic manually by being deliberate about the context you provide. Before we wrap up, here is a quick look at where this is all heading. Researchers are working on new model architectures that handle very long contexts more efficiently and more accurately. There is also growing interest in models that can maintain a kind of long-term memory outside the context window entirely, learning from past conversations over weeks or months. The 2025 generation of models is already beginning to blur the line between a context window and something closer to persistent memory. Tokens and context windows are not just technical trivia. They are the reason AI tools behave the way they do, the reason they cost what they cost, and the key to using them well. Every time you craft a prompt, choose a model, or wonder why an AI seems confused, the answer is almost always somewhere in these 2 concepts. Now you know where to look. If this video helped you understand something that felt confusing before, hit the like button. It genuinely helps other people find this content. Subscribe if you want more clear, practical breakdowns of how AI actually works under the surface. Next up, we are going to cover prompt engineering fundamentals, the exact techniques that get you better results from any language model, starting with the first word you type. See you there.